This is GCSE Mathematics Practice Set 8, Paper 3 for the Edexcel higher tier. As always, Paper 3 is a calculator paper and mark scheme in the description if you want those. Let's get straight into it. Question 1 says 3 numbers have a mean of 17, a median of 20, and a range of 27. Find the 3 numbers. So for this you need to know what the mean and median are. The median is the middle value, so if you have 3 numbers, the middle one's going to be 20. So let's write 20 down. And then I have some other number after it, so y, and then some other number x, and those 3 numbers added together and divided by the number of numbers I have, so 3, is going to be the mean. So I need to add these together, and then I can kind of do some algebra here, so multiply by 3 on the right hand side, and well, let's just do that first. So I might just write that numerator slightly differently as well. I have x plus y plus 20 equals 17 times 3, that's 51. And then if I subtract that 20, all I'll be left with on the left hand side is x plus y. 51 take 20 is 31. And now once you get to this point, you need to use the range of 27. So the difference between those is 27, and they also add to 31. So what 2 numbers have a difference of 27 and a sum of 31? For this you could just use trial and error. So you could try maybe 3, and what would add to 3 to make 31? That would be 28. That doesn't work, right? 28 plus 3 is 31, but the difference there is only 25, so the range would not be correct. Then you could try maybe 1 plus 30. Okay, that makes 31, but the difference there is 29. And then try 2 plus 29. 29 plus 2 is 31, and the difference there is 27. So then you know that those 2 numbers are x equals 2 and y equals 29. Okay, and we know the middle number is 20. So therefore the 3 numbers must be 2, 20, and 29. Okay, that was question 1 for 3 marks. Question 2 gives us a diagram. It says ABCD is a parallelogram, EDFC is a straight line. Write down the size of angle X. Okay, so you need to know about parallel lines here. If this is a parallelogram, then AB is parallel to DC, or EDFC, as they state it here, is a straight line. So these 2 angles are what are known as alternate angles with respect to parallel lines, and alternate angles are equal. So we can say x is going to be 67 degrees, and you could state as a reason the alternate angles are equal. Okay, that was part A. Part B says work out the size of angle y. So y is up here. Well, for this we could look at this triangle in here, FBC. That's one way to do it. So you could say, for example, this angle in here is BFC is 180 take 120, because of angles on a straight line add up to 180, so that must be 60. And you also should know that opposite angles in a parallelogram are equal, so this would be 67 degrees over here, opposite x, which we found before. And important to note that for part B, it doesn't say you need to give reasons, it just says work out the size of angle y. So if it doesn't say give reasons, you don't need to write down any of that reasoning, you just need to show a little bit of working out. So for y there, I would say, well, looking at this triangle BFC, the angles in the triangle add up to 180, so these 3 angles need to add up to 180, so therefore y is going to equal 180 take 60 take 67. And well, that's going to be 127, 180 take 127 is going to be 53. Okay, so that's for part B. That's all I would use for that. Again, just to be clear, if it says give reasons for your working out, you need to give reasons for all of these angles in here. Alright, so that was question 2 for 4 marks. Question 3 says the table gives information about the number of trees in each of 20 gardens. Okay, so number of trees 0 to 5 and the frequencies. Part A says work out the total number of trees in these gardens. 2 gardens had 0 trees, so that's going to be 0 trees to add up. 7 gardens had 1 tree, so that would be 7 trees in total. 3 gardens had 2 trees, so therefore would have 6 trees in those 3 gardens. 4 gardens had 3 trees, that would be 12. 3 gardens had 4 trees, again that would be 12. and one garden had 5 trees, so that would be 5 trees in that one garden. So basically what we're doing is multiplying the number of trees by the frequency, and then let's add these up. So what's the best way to do this? 12 plus 12 is 24, plus 6 is 30, 37, 42. Okay, so total number of trees 42. Part B says find the median number of trees in these gardens. Well, the median is the middle value. So what does that mean for a frequency table? Well, the first thing you could do is work out the median position, and that involves looking at how many gardens we looked at. So it says in the question there were 20 gardens, so the median garden would be, well, we add 1. If it's an even number, we add 1 to it, so we do 21 divided by 2. That's going to be the 10.5 position. That would be the median garden. And then if we look at the table, count up on the frequencies, we've got 2 plus 7 is 9, and the 10th garden will have 2 trees, and the 11th garden will have 2 trees. So because that 10 and 11th garden are both in this category here with 2 trees in it, we can say that the median number of trees is 2. So final answer for the median is 2. Question 4 says Charlotte earns $8.50 per hour. She gets a pay rise of 6%. Work out how much Charlotte earns per hour after her pay rise. So for these percentages questions in a calculator paper, it's useful to know about the multiplier. The multiplier is how we increase something by a percentage. So we add that percentage to 1 if we're increasing, because it's a pay rise, it's going up. We would multiply it by 1.06. So 1 plus that percentage is our multiplier. 850 times 1.06, might as well use a calculator for that. 8.5 times 1.06, and we get 9.01. 9.01 pence. That was question 4 for 3 marks. Question 5 gives us a diagram. It says on the grid enlarge shape P with scale factor 3 and center A. Okay, this is an important skill to know for your GCSEs. You can start off by drawing enlargement lines, or I'm not actually sure what these are called, but lines from the center of enlargement through the vertices of that shape. So now you don't necessarily have to do all of them. You'll see what I'm talking about in a minute, but try to firstly look at the position of the center of enlargement away from the vertices. So I can see this is 1 up and 2 across. So for when I'm extending that line, I need to make sure I'm going through where those grid lines intersect, where I go 1 up and 2 across, 1 up, 2 across. So that should be a bit over a bit. So you can see I've slipped up a little bit there. This one's down 1 and 3 across, so down 1, 3 across. It makes sure your grid lines are accurate if you look at it that way. And for this one, it's going to be straight across through those 2 vertices there. And I'm going to leave that one off, and you'll see why in a minute. Sometimes you don't have to do all of them. Okay, so I've got a scale factor of 3. That means I need to multiply the distance away from the center of enlargement to the vertex by 3. So this position is 1 and across 2. I need to do that twice more, because that distance, that total distance from the center of enlargement needs to be 3 times the original distance. Okay, so this distance, if you want to think about it, you might think of that as 1 unit. Then the resulting distance after the enlargement needs to be 3 times that. So go 1 up and 2 across, 1 up, 2 across, 1 up, 2 across, 3 times from A, and you'll get to our new point here. So this is times 3. Same for this one. Go starting at the center of enlargement, go 1 down, 3 across, 1 down, 3 across, 1 down, 3 across. Do that 3 times, and you get to our new point here. That was the bottom there. About this one, well, I've just gone 2 across, and do that again, and then do that once more. And you could also do it for the other point. Starting at the center of enlargement, I need to go 1, 2, 3, 4. Do that twice more, and you'll get to your new point. Okay, and you should also notice once you start seeing this new shape, so you can see this side here would be lining up with this side over here. Once you start seeing that and join them up, that side should be 3 times the original side. So this side was 1 unit or 1 block of this grid. This one's 3, so you can see you've done it correctly. And then obviously this is going to join up to the bottom down here, and you can see now that point is obviously going to be over here in line with all of the other points. So I didn't really need to draw that grid line because once I've got the rest of that shape, it becomes clear where it should be. And then do one final check. So look at the other sides. The original side of this shape was 1, 2 units. So this one should be 6, 2, 4, 6. This side is 6 units in length. So you can see that you've enlarged it by a scale factor of 3. All the sides should be multiplied by 3. Okay, so that is how you're enlarging a shape with a center of enlargement. On to part B, it gives us a grid and it says describe fully the single transformation that maps shape R onto shape T. Now for these you might like to use a tracing paper if you're used to that, and also I'll just point out at the start of the paper it does say, where does it say this? Oh, up the top here, tracing paper may be used. So that should be available to you in an exam situation. They should make that available to you. So one thing you can do is put the tracing paper over the top, draw that shape on, and then try to find the center of rotation. So why do I know this is a rotation? Well, because this shape here has clearly been rotated from R. So it's not in the same alignment as shape R. So it's been turned a little bit. And because it's a single transformation, I can fairly confidently say it will be a rotation. Now you can get a shape changing its alignment without rotation, but I'm fairly confident because also it looks to be the similar distance from the center, around about the center. So first thing I would do would try the center O as my center of rotation and see if that works. So if you've got a piece of tracing paper, put your pencil down, trace over the R on the tracing paper, put your pencil down on the center, and then rotate that paper around and see if that shape ends up on shape T. And if it does, keep track of how much you've rotated that paper. So it's either going to be one turn or half a turn or a full turn, and that's going to be equivalent to 90 degrees, 180 degrees, 270 degrees, or 360 degrees. It should get you back to the point where you started. But if you take the tracing paper, that's one way to help, or you can look at how far these points are from the center. So if I go, for example, if I go left 2 and down 1, and then if I rotate that, that's going to change. That's going to change to 1 across and 2 down, and I get to that same point there. For this point, I need to go 2 to the left and 2 down, and then if I rotate that around, I'd be going 2 to the right and 2 down, and I get to that point there. So I'm pretty confident now that I can say this is going to be 90 degrees because I'm turning these distances 90 degrees around the center to get to the new point on the new shape. A few different strategies to do these types of questions, but my final answer there is going to be rotation. So it's either clockwise or anti-clockwise. You could also say anti-clockwise 270 degrees, but clockwise is what I'm saying. Clockwise 90 degrees about 0, 0. Okay, so you need those 3 or 4 details. You need rotation, the direction clockwise, you need how far it's been rotated, and you need the center of rotation. That's question 5 for 5 marks. Question 6 says a plane flew from Sydney to Wellington. The distance the plane flew was 2,240 kilometers. The average speed of the plane was 805 kilometers per hour. Work out the time taken by the plane to fly from Sydney to Wellington. Give your answer in hours and minutes, correct to the nearest minute. Okay, so for this, you need the speed, distance, time formula. And using that triangle relating speed, distance, and time, you know that time equals distance divided by speed. So we've got the distance, we've got the speed, so all we really need to do is plug those in. 2,240 divided by 805, and that gives you 2.7826, 2.7826, and it goes on. And important to think about what units that would be in. Well, the speed is in kilometers per hour, so the time then ends up in hours. So this is in hours in decimal form. So when you get this answer, you need to take that decimal part. So one way to do this is take that answer and subtract 2. Then you end up with that decimal part of that number. That's going to be your minutes. So to convert that decimal number into minutes, you need to multiply by 60. that's going to give you the number of minutes. So this is 46.9565 minutes. Because it says round to the nearest minute, I can round this off to the nearest whole number. That's what this means. So look at the first decimal place. Is it more than 5? Yes, it is. So I need to round that 6 up to 7. 46 rounds up to 7. 47 will be rounded to the nearest minute. So this is going to be 2 hours and 47 minutes. So it's important to know how to convert decimal numbers into hours, minutes, etc. by multiplying that part by 60. So I just took that bit and multiplied by 60 and then rounded off to the nearest whole number. Okay, that was question 6 for 3 marks. Question 7 says solve the simultaneous equations y equals 4x and 7x take equals negative 13.5. For this one, because they've given you that first equation clearly in terms of y, I would substitute that straight into the second equation. So y equal to 4x, therefore we would have 7x take 4x. So I've substituted that value for y into the second equation here, and this equals negative 13.5. And then you can solve for x. So 7x take 4x is 3x equals negative 13.5, and then x is going to be 13.5 divided by 3. And I'm feeling lazy, so I'm just going to do that on a calculator. 13.5 divided by 3 is 4.5, negative 4.5, and then substitute that into the original first equation. So y equals 4 lots of x, 4 times 4.5, that's 16 plus 2, so y is going to be negative 18. Alright, so final answer there, negative 4.5 and negative 18 for y. Okay, that was question 7 for 3 marks. A, B, and C are 3 cities. And we have a diagram here. City C is due east of City A and due north of City B. City A is 43 kilometers from City C and 70 kilometers from City B. Okay, so that's indicated on the diagram here. Work out the bearing of City B from City A. Give your answer correct to the nearest degree. Okay, so because they tell us C is due east of A, and we have that north bearing there, we know this is going to be a 90-degree angle in here. So to work out this bearing, what we're left with is we have to work out this angle in here. And we can work that angle out using the trigonometric ratios because we're given 2 sides of this right angle triangle. And if I'm given the adjacent side and the hypotenuse, which trigonometric ratio do I need to use? That will be the cosine function, because the cosine of an angle equals the adjacent over the hypotenuse. So therefore, I would start off by stating that. I would say cosine of theta equals adjacent over hypotenuse. Therefore, theta is going to be the inverse cosine of 43 over 70. So plugging those sides into that formula there. And we're going to get an approximation here. So let's put that in. So the inverse cosine of 43 on 70, I get 52 approximately, rounded off, so rounded off to 52 degrees, because the question says give your answer to the nearest degree, so I can round that off. Therefore this bearing is going to be 90 plus 52, 90 plus 52, that's 142, it just says work out the bearing of B from A. Remember, a bearing is clockwise from north, the angle clockwise from north between that between north and that direction you want to go in. So 90 plus 52 is 142 for that bearing. Okay, 4 marks for question 8. Question 9 says simplify 3a squared b to the power 4 all cubed. For this you need to know that the exponents you multiply when you're given a term in brackets like that. So that's going to be 3 to the power 1. 1 times 3 is 3, so that would be 3 cubed. Multiplied by 2 times 3 is 6, so a to the power 6. And then 4 times 3 is 12, so b to the power 12. And also simplify 3 cubed, so my final answer here would be 27a to the power 6, b to the power 12. Question 10 says solve the inequalities. Negative 5 is less than or equal to 2p plus 3 is less than 13. Similar to how you would solve an equation. So firstly, subtract 3 not only from the 13 but also from the left as well. So if you've got 2 inequality symbols there, you need to subtract that 3 from the left and the right hand side. So my first line of working out here would be 2p less than 13 take 3 is 10. and negative 5 take 3 is negative 8. And then to get rid of that 2, divide both sides by 2, and you'll have negative 4, and then p is greater than or equal to negative 4 and less than 10 divided by 2 is 5. Okay, so my final answer there, p between negative 4 and 5. Okay, that's question 10 for 3 marks. Question 11 says a group of 15 businessmen were asked to give the number of different countries they had each visited on business. Here are the results. Okay, so one person visited 0 countries, one person visited 14 countries, and all of those in between. It says work out the interquartile range of the number of countries visited. When you're talking about discrete data like this, take the number of things you're talking about. In this case, we're talking about 15 businessmen. Add 1 to it and divide by 2 for the median and divide by 4 for the lower quartile. So 16 divided by 4 is going to be the lower quartile. 16 divided by 4 is 4. The upper quartile is the lower quartile times 3. So this is the lower quartile. The upper quartile is 4 times 3 is 12. Okay, so that is the 4th position here. So the 4th businessman will be the position of the lower quartile. So 1, 2, 3, 4, lower quartile, and then count back. It's going to be easier. So 15, 14, 13, 12 for the upper quartile. And the interquartile range is the difference between these. So the difference between the actual number in that position. So 3 is the number in the 4th position. 10 is the number in the 12th position. So the interquartile range is going to be 10 take 3, which is 7. Final answer 7 for question 11. Question 12 says solve 5x take 2 over 3 plus 3 take 5x over 4 equals 2. Show clear algebraic working. Okay, so for this one, we need a common denominator. The lowest common denominator of 3 and 4 is the same as saying the lowest common multiple. Lowest common multiple of 3 and 4 is 12. So what I want to do is multiply this first fraction by 4, this one by 3, and we'll be able to combine those fractions together. 5x take 2, we're multiplying by 4, and 3 take 5x, we're multiplying by 3, and because the denominators now both become 12, we combine them together with a denominator of 12, and this equals 2. Now, if you're good at algebra, that's going to be the most difficult part because now you're rearranging and solving this equation for x. So the first thing I would do is multiply by 12 on the right hand side to get rid of this denominator and expand out those brackets. Expanding brackets, you would do 4 times 5x is 20x, and 4 times 12, that's 48. Oops, where did I get 12 from? That should be 2. I'm not sure why I wrote 12 there, sorry. So 4 times negative 2 is negative 8, and then 3 times 3 is 9, and 3 times negative 5x is negative 15x, and this equals 12 times 2 is 24. Okay, keep simplifying. 20x take 15x is 5x. Negative 8 plus 9 is positive 1 equals 24. Subtract that 1 from the right hand side, we'll have 5x equal to 23, and then the last final step is to divide by 5, so x will equal 23 divided by 5 for your final answer there. And you can also give that as a decimal if you like. Now, usually I would suggest going back to the original equation and double checking, so inserting that 23 on 5 into the original equation. A little bit difficult here, although actually that 5 would cancel with each 5 here, so you'd just be left with 23. Okay, so it's not so difficult to check. You'd have 23 take 2, 21 divided by 3 is 7, and then 3 take 23, that's negative 20. So you'd have 7 here, subtract negative 20 divided by 4, that's negative 5. So 7 take 5 is 2, so that works. So okay, not so difficult to double check that in the end. Okay, so that was question 12 for 4 marks. Question 13 says the population of China is 1.4 times 10 to the 9. The population of Morocco is 3.5 times 10 to the 7. The population of China is k times the population of Morocco. Work out the value of k. Okay, so if something is k times something else, then, well, let's just write this down. So the population of China is 1.4 times 10 to the 9 equals k times 3.5 times 10 to the 7. Okay, to work out k, we want to divide 1.4 times 10 to the 9 by this. So k is going to equal, well, write that out again, divided by 3.5 times 10 to the 7. Okay, now looking at these numbers, you can kind of separate it into 1.4 divided by 3.5 and 10 to the power 9 divided by 10 to the power 7. So this part here, 14, kind of think of this as 14 over 35. They're both multiples of 7. So if you divided them both by 7, you'd have 2 over 5. 2 over 5 is the same as 0.4. So that's going to be 0.4. Or just don't be silly like me, and you could just check that on a calculator. So 1.4 divided by 3.5 is 0.4. And then 10 to the 9 divided by 10 to the 7, subtract the exponents. You need to know your index laws. Same base, subtract the exponents. 9 take 7 is 10 to the power 2. And so therefore, value of k is 0.4 times 10 to the power 2, or 0.4 times 100. If you're good with multiplying by powers of 10, which is something you do need to practice, you know this is going to be 40. So 0.4 times 100 is 40. Final answer there for question 13 for 2 marks. Question 14 says Genevieve has 2 bags of marbles, bag A and bag B. In bag A there are only 3 red marbles and 4 green marbles. In bag B there are only 4 red marbles and 5 yellow marbles. Genevieve takes at random 1 marble from each bag. Part A says complete the probability tree diagram. Okay, so 2 different bags, that's important to realize. Bag A, there are 3 red and 4 green marbles, so the probability of picking green is going to be 4 out of 7. Bag B, we have 4 red marbles, so in total 4 and 5 make 9, so the probability of a red will be 4 out of 9. Yellow will be 5 out of 9, and they're going to be the same for the second for this second branch here as well. So 4 out of 9 and 5 out of 9. Okay, shouldn't be too many problems there. Part B says work out the probability that Genevieve takes 2 red marbles. So one strategy you can use here, if you're given a tree diagram like this, is highlight the branches that you need to focus on. So the probability of 2 red marbles, well, the first red marble will be this branch, and then we're not going to worry about this yellow one because we want to pick 2 red, so the second branch will be this branch here. Now once you've highlighted that branch in the probability tree diagram, what you want to do is multiply the probabilities along that branch. So 3 over 7 multiplied by 4 over 9 is going to be your probability for 2 red marbles. So 3 over 7 multiplied by 4 over 9, that will give you your final probability. Now sometimes you might be looking for 2 different branches and you'll need to add those together. In this case, we only have 1 single branch we're worrying about, so this is going to be all the working out we need to do. 3 times 4 is 12, 7 times 9 is 63, and that would be fine for a final answer. You can simplify this as well down to 4 over 21. It doesn't say to simplify, so 12 over 63 would be fine, or you could say 4 over 21. Either one of those would be fine for 2 marks. So that was question 14 for a total of 4 marks. Question 15 says, make W the subject of the formula P equals the square root of W plus 4 over W take 2. In my opinion, this is about as difficult as these make the subject of questions get, because you have a fraction here with W in the numerator and denominator. So that can be quite difficult. But let's firstly start off by squaring both sides to get rid of this square root. That's usually your first step. If you've got a square root in there, you want to square both sides to get rid of that. So on the left, P squared is P squared. On the right, we'll get rid of that square root and we'll just have W plus 4 over W take 2. This is where it gets a bit tricky because we want to separate all of the W's onto the left hand side by themselves. Now how are we going to do that? Well, take it in steps. You can't get them all over to the right hand side straight away. You can't separate this fraction into W over W. It doesn't work that way. Firstly, multiply by W take 2. So we'll have P squared multiplied by W take 2 equals W plus 4. We're going to take this in stages. Next, expand those brackets out. WP squared take 2P squared equals W plus 4. Now is where you can get those W's on the left hand side together. So firstly, get rid of this 2p squared over to the right, add it to the right hand side, and subtract that w on the left. We'll have wp squared, take w equals 4 plus 2p squared. Okay, once you've got them all together like that, factorize out the w from both terms here. And that's how we're going to isolate that w. So factorize the w, in the brackets we'll have p squared take 1 equals 4 plus 2p squared. And now divide by that p squared take 1, and we'll have w all by itself on the left. Okay, so a number of steps there to eventually get w isolated and make it the subject, but hopefully all of that makes sense, and we end up with w equal to 4 plus 2p squared over p squared take 1. Again, that's about as difficult as those types of questions get, in my opinion, where you have the numerator and denominator containing that subject that you want to make. So final answer there, w equals 4 plus 2p squared over p squared take 1. Question 15 for 4 marks. Question 16 says the incomplete histogram and table give information about the lengths of time in minutes that some people spent at an airport. Okay, so here we have the table. It is incomplete, as they say, and well, these are the times and the frequencies that people stayed at the airport. Okay, fine. Here's the histogram. Part A says use the histogram to complete the table. Okay, what's the issue with this histogram? We don't know the scale on the frequency density. We're going to have to figure out this scale here. So we had a similar question in paper 2. We had to figure out the scale. So that's the real problem here. What is the scale? And we can use that information in the table already to figure that out. So for example, if we look at this bar, this is going to be 50 to, what's the scale on the bottom one? Well, this would be 25. This is 10, 20, 30, 40, 50. Okay, so every 2 is 10. So this would be 10, 20, 30. This would be 80 here. And we have a height here of 10, 25. So this is 25 grid lines. That's not the scale. I'm just saying there's 25 grid lines up to that point. You also need to know how to work out the frequency density. So the important part here is to know that the frequency density, to work that out, you do the frequency, this column here, divided by the class width, which is the width on the bar and also this width in here. So if we look at that bar 50 to 80, that's a class width of 30. We have a frequency of 15, so the frequency density here, maybe I'll make a new column, frequency density is going to be 15 divided by 30. Okay, that's 0.5. Alright, so 25 of these little grid lines on the vertical axis is 0.5. 0.5 here on the vertical axis. So looking at these major grid lines on the vertical axis, 1, 2, 3, 4, they would be, each would be 0.1 in terms of the frequency density, okay? And that means that each little one is 0.02, 0.02, 0.04, 6, 8, okay. All right, so we've worked out that scale. This one will be 0.3, etc. Okay, that's good. And once we've got that scale, we can work out the rest. So for 80 to 120, the frequency density there would be 0.6, 0.7. So now we can also use this formula to work out the frequency. So the frequency is the frequency density times the class width. So in this case, where we're missing the frequency, we need to do the frequency density, which was 0.7 multiplied by 40. 7 times 4 is 28, so 0.7 or 70% of 40 would be 28, okay? So frequency 28 there, and then we can use the same approach for the second missing part here, 120 to 180. 120 to 180 is this bar in here. That is a frequency density of 0.3. So 0.3 times the class width, 120 to 180 is 60. 0.3 of 60, well, 3 times 6 is 18, so 30% of 60 is 18. And we are done with completing the table. Okay, so I guess I'm not really sure what working out they'd want you to show, probably none. You can just put the answers in there for those 2 marks, and that would be fine. Part B says use the table to complete the histogram. Okay, so now we need to draw in the bars for the other rows here in this table. So for the first one, we have a frequency of 10 and a class width of 50. So using this idea, frequency density equals frequency divided by class width. 10 over 50 is 1 over 5 is 0.2. And so that is here on my vertical axis, 0.2. So I just need to draw that line, all done. Then the other ones, I need to work out the remaining bars on the end here. Class width here, 180 to 240 is 60. 12 over 60, I know 12 goes into 65 times, so this would be like 1 over 5. Again, this would be 0.2. And class width for the last one, 240 to 320, that's going to be 80. Okay, 8 on 80. Okay, that's a bit easier. 1 on 10 is 0.1. Okay, so I have the frequency densities for those last 2 bars, 0.2, and I need to go up to 240. Okay, I need to find that on the horizontal axes. That would be here, and I need to go up to 0.2. So each one was 10, wasn't it? Each 2 bars was 10. Okay, that one is done, and then up to 320, 310, 320 would be here, and that was 0.1. So down to 0.1 and across to 320. Okay, once we've got those bars in, we've completed the histogram and we're done. So that should be everything for question 16 for 4 marks. Question 17 gives us a diagram. It says the diagram shows a rectangular piece of card with length 2x plus 1 and width x plus 3. A rectangle of length 3 centimeters and width 2 centimeters cut out of the card. The area of card that remains shown shaded in the diagram is 45 centimeters. Show that 2x squared plus 7x take 48 equals 0. Okay, so obviously this question part A is related to all of this up here. They're not just saying randomly show that this quadratic equals 0. You need to use all of this information to get to that. Well, firstly, I would suggest just trying to work out an expression that relates to this shaded area or the area of this rectangle. So for starters, you could say the area of this large rectangle is the width times the length. So 2x plus 1 times x plus 3. That would be where I would start. So 2x plus 1 times x plus 3. Now what we want to do is to relate it to the area they give us, 45 centimeters squared. They've told us that that's the shaded area in here. Well, that was minus this card they cut out. Now what's the area of this cutout card? That will be the length times the width. 3 times 2 is 6. And if we take that away from the large rectangle, that will give us the shaded area, right? You need to understand this about shapes where you cut a section out. To find the remaining area, you find the area of the larger shape and subtract the area that they've cut out, or the area of the smaller shape, to get that remaining shaded area. So the large rectangle, take the small rectangle, 6 is going to equal that 45 centimeters squared that they give us. All right, now we've got an equation. Let's try to simplify this down to the quadratic that they were asking us to show. So firstly, expand out these brackets using FOIL. So first, 2x times x is 2x squared, outers, plus 3 times 2x is 6x, inners, 1 times x is just x, and then 1 times 3 is positive 3. Take 6 equals 45, and then keep simplifying. So in other words, combine like terms. 2x squared stays as is. 6x plus x is plus 7x. Then we have this 3 takes 6, that's negative 3. And we also need to subtract that 45 from the left-hand side as well. So we'll have that negative 3, take 45, that's going to be negative 48. On the right, we are left with 0 because I've subtracted that 45 from the left-hand side. And now, well, you can see we've shown that 2x squared plus 7x take 48 equals 0. Okay, all good there for 2 marks. Part B says find the value of x, show you're working clearly, give your value of x correct to 3 significant figures. All right, let's go ahead and try to solve this quadratic. So I would probably just write it down below. You don't have to do this, but I generally just use that as a good starting point. Try to factorize this. see if you can find factors of 48 and 2 that sum to 7. So factors of 48, 8 and 6, I'm just not seeing how this is going to factorize. So what I'm going to do is use the quadratic formula. So the quadratic formula says x equals negative b plus or minus the square root of b squared take 4ac all over 2a. And by the way, the other clue that's telling me this might not factorize is the fact they say give your answer correct to 3 significant figures. Usually if something factorizes, you're not having to round that off. You're going to get a whole number or a fraction answer. So if it's saying round off to 3 significant figures, usually that's a clue you'll need the quadratic formula. So anyways, this is a quadratic formula. We need to plug the numbers in. B is the coefficient of x. So this is going to be negative 7 plus or minus the square root of b squared. 7 squared is 49. Take 4 times 2. A is 2 and C is negative 48. And this is all divided by 2a. 2 times 2 is 4. Okay, from here I would probably plug that straight into a calculator and do the positive and negative each separately. So negative 7 plus all of this, so the square root of all of that. Okay, once you've entered that all correctly, and it might be easy if you have a fraction button on your calculator, check if you have a fraction button, but enter it all correctly, you will get 3.4521 or 3.452, so 3.452, etc. And then do the negative. Now, if you have an entry button on your calculator, try to find that. It makes it a lot easier because you can get the last entry put in and change that positive to a negative, and it saves you having to type all that out again. And do the negative answer and you get negative 6.95, etc. And now you have two answers, so you need to check which one fits. So let's go up to the diagram again. So let's, for example, look at this negative 6.95. Is that a possible answer? So let's, for example, look at this one here. Well, we know that a length needs to be greater than 0. So you could say 2x plus 1 needs to be greater than 0. That's a length. It must be larger than, it can't be negative, in other words. So then you can use this inequality to find what x needs to be greater than. So subtract 1 and divide by 2. X needs to be greater than negative a half. Do the same thing over here. X needs to be greater than negative 3 for this to be greater than 0. But this one tells us that x needs to be greater than negative a half, in which case negative 6.95 is too small an answer to use. So therefore we have one possible answer. It's 3.45, 2, and so on. And then to round that off to 3 significant figures, that would be 3.45 for my final answer there for x. So and that is in centimeters. Okay, so that should be good enough for 3 marks, and that was question 17 for a total of 5 marks. Question 18 says, use algebra to show that the recurring decimal 0.278, where 78 are recurring, equals 46 over 165. Okay, a fairly standard method to doing these types of questions, and maybe you've seen me do this before, but let's go through it in as much detail as I can. So firstly, we say that x equals this recurring decimal, 0.278 recurring. Next, we multiply these by 10 until we get two numbers with the same recurring part. So, for example, multiply both sides by 10 and I get 10x on the left, and then on the right here I get 2.78 recurring. Next, if I multiply that by 10 again, I'd get 27.87 recurring. The recurring number wouldn't be the same. So multiply it by 100, I'll get 1000x. So I'm multiplying by 100 here, and I get 1000x on the left-hand side. On the right, I get 278.78 recurring. And now you can see the recurring part of that number is the same. So that's the whole point. Then what we can go ahead and do is we can take these two equations, subtract them. So 1000x take 10x equals 278.78 recurring, take 2.78 recurring, and now because we're subtracting these numbers with the same recurring decimals, they cancel out. That's the whole point of this whole process. And then essentially solve this equation for x. So 1000x take 10x is 990x. 278 take 2 is 276. Divide by 990, x equals 276 divided by 990. And now, remember we're trying to show it equals 46 over 165. Now we want this fraction to simplify to this. Now you might have a calculator which allows you to put in a fraction. So 276 divided by 990, and you might have a button that allows you to simplify that fraction. So in this case, I can go to fraction on mine, and it gives me the simplified fraction, 46 over 165. Another way you could do is just divide 276 by 46, and hopefully it gives you a nice whole number, and then multiply 165 by 6 and hopefully get 990. Either way, this is going to simplify to 46 over 165, and therefore we've shown that recurring decimal equals 46 over 165. That's what it means when it says use algebra to show this. Okay, that was question 18 for only 2 marks. Despite the amount of work you need to use there, I guess the justification is that this is a fairly standard method of doing these, and most people should know how to do this, and there's not really any problem solving involved here. It's kind of mechanical. Okay, so anyways, let's move on. Question 19 says express x plus 3 over x take 4, take x plus 4 over x take 3 as a single fraction. Simplify your answer. Okay, so to find the lowest common denominator, we want to multiply this fraction by this denominator and multiply the second fraction by the first denominator. So what we're going to end up with here is x take 3 times x plus 3, subtract x plus 4 times x take 4. So I've multiplied those numerators by the diagonal denominator, and then the denominator becomes those two denominators multiplied. And now you're essentially simplifying. So the first thing I would do is expand these brackets. This is the difference of 2 squared. So I know that this is going to be x squared take 9. If you're not familiar with the difference of 2 squares, then expand that out. You'll still get x squared take 9, so that's absolutely fine. And then subtract this. Again, this is the difference of 2 squares. This will be x squared take 16, so the second term squared. And make sure you put that in brackets because that negative is going to be expanded to both terms there. And in the denominator, we still have x take 4 multiplied by x take 3. Now there's no difference between expanding that denominator or leaving it as is, so you might as well save yourself some work and leave it in 2 brackets like that. There's no need to expand it to simplify. Then keep simplifying the numerator. X squared take x squared, they will cancel out, and we'll be left with negative 9 plus 16. That negative times a negative 16 will be a positive 16. Negative 9 plus 16 is 7. So final answer there, 7 over x take 4, x take 3. Okay, I don't know why I wrote it there. I'll just write it over here for a final answer. That was question 19 for 3 marks. Question 20 says 5 to the power of n squared divided by 5 to the power of 6 multiplied by 5 to the power of n squared take 5n over 5 cubed equals 125, where n is greater than 0. Work out the value of n, show clear algebraic working. Okay, so for this one, you really need to really solidly understand your index laws. So firstly, I'm going to simplify this left-hand side because it looks really messy at the moment, but because we have the same base number, remember this is what we call the base number. If we have, say, 10 squared, this is the base number. If we have the same base number, we can subtract the exponents when we are dividing those numbers. So 5 to the power of n squared divided by 5 to the power of 6, we can write as 5 to the power of n squared take 6. So I've subtracted those exponents because I'm dividing numbers with the same base. Then this is multiplied by all of this. I can write as 5 to the power of n squared take 5n take 3. Again, I've subtracted those exponents and simplified it that way, and this is equal to 125. Now another thing you need to understand here is this is going to involve writing everything as base 5 in order to equate the exponents. So 125 is clearly not base 5, but hopefully you know the cube root of 125 is 5. In other words, 5 times 5 times 5 equals 125. Therefore, we can write 125 as 5 cubed. So now we have everything as a number base 5. Next, keep simplifying this left-hand side. When we are multiplying numbers with the same base, we can add the exponents. So I'm using basic index laws here in a complicated question, but that's all I need. As long as you understand them really well, you should be fine for this question. So I'm going to add this exponent plus this exponent here, n squared take 5n take 3, and this equals this exponent over here. So because I know that when I multiply the same bases, I add those exponents, that will equal this exponent on the right hand side. All of this should equal 3. Alright, next, keep simplifying. N squared plus n squared is 2n squared. Combine like terms, there's no other n terms, so this will just be negative 5n. Negative 6 take 3 is negative 9, and then also take this 3 from the right hand side. This would be negative 9 take 3 is negative 12, and this would equal 0 because there's nothing left on the right hand side. Then we have a quadratic, and all we need to do is go ahead and see if we can factorize this. So look for factors of 12 multiplied by 2 that make 5. The obvious ones jumping out at me are 3 and 4. Now, can I have a difference of 5 there if I multiply 1 by 2? So what would we have to do there? We can use the cross method, or the factors of 2 are 2 and 1, and then 4 and 3 for 12. Now, if I multiply 2 by 4, that would give me 8, and 1 by 3, that gives me 3. Then I have a difference of 5. Great, perfect. So I know then that I can factorize this into 2 brackets. My first terms will be 2n and n, and in the second terms I'll have 4 and 3, making sure to write those in the correct places. 2n times 4 is 8, and n times 3 is 3, and I need a negative 5, so this will be negative 4 and positive 3. This equals 0. Next, solve for n. So n is either going to equal negative 3 on 2, or n is equal to positive 4. And go back to the question again. It said n is greater than 0. Work out the value of n. So in this case, for this solution, it's not valid because it's less than 0. So I would say as n is greater than 0, n equals 4. So final answer there for question 20, n equals 4. Alright, on to the next one. Question 21 gives us a diagram. It says the diagram shows a pyramid with a horizontal square base. The vertex P of the pyramid is vertically above the center O of the base. The triangular faces of the pyramid are congruent isosceles triangles. In triangle ABP, that's that face there, PA equals PB. Okay, so that means that those two sides are equal. Equals 11. Okay, they've already drawn that one. And angle PBA equals 72. Okay, they've indicated that as well. Work out the height OP of the pyramid. Give your answer correct to 3 significant figures. Okay, so again, we're looking at a 3-dimensional shape here. That's important to note because we need to think 3-dimensionally. Sometimes that can be hard, but firstly, this is an isosceles triangle, so this angle in here is going to be 72. And that allows me to find the angle at the peak of this triangle. That's going to be important, but firstly let's write that down. So angle APB equals, the angles in a triangle are 180, so I can work this angle out by taking these two angles from 180. 180 take 72 plus 72 is 144, so 180 take 144. That's going to be 36. Okay, I know that angle at the peak of that triangle now. How does that help me? Well, I can use the law of sines to work out the other lengths of this triangle because they've given me one length and I know all of the angles. So the law of sines says that A over sine A equals B over sine B. And this is relating the sides of the triangle to the angles. Now for this one in particular, I want to work out AB. So I have the angle opposite AB, 36, and I have angles 72 and 11. So plugging those in here, I can work out side AB Okay, that's relating to A in this formula. This is going to be equal to B over sine B. Again, I'm substituting 11 for B, and angle B is 72. So 11 over sine 72 multiplied by sine A. A was 36, so sine of 36. That's going to allow me to find this side here. So let's plug that into a calculator. 11 divided by sine 72 multiplied by sine of 36, and that equals 6.798, etc. 6.798. Okay, next let's go back to the question just to show like how this is fitting together, how this is making sense. Remember, we're looking for the height of this pyramid, and what I'm trying to do is figure out the other sides of this right angle triangle here. So if I draw a right angle triangle, please really try to think three-dimensional here. I've drawn a right angle triangle from P to this edge back to the center of the pyramid, and I know that's a 90-degree triangle because if you're looking for the height of a pyramid, that's going to be the perpendicular height. So that line must be perpendicular to the base. So I've got a right angle triangle here. I've worked out the length AB. This line PM is going to bisect AB. And the reason I worked out AB is so I can know the length OM. Now I could have also drawn this triangle over here, so there's really no difference either drawing it over here or over there, doesn't matter, but this length here OM here is going to be half that length AB because all of these sides are equal. Okay, so that's why I worked out side AB to know this length. Next I have to work out length PM, and then I can use Pythagoras' theorem to work out the height. So length PM is the next thing I want to work out. And for that, because this line is perpendicular to this edge, I can use the sine ratios. So looking at this right angle triangle, the sine of an angle is the opposite over the hypotenuse. So the opposite side is what I'm looking for, line PM. So the formula I'm going to use here is sine 72 equals the opposite over the hypotenuse, which is 11 in this particular triangle, and that opposite side, instead of saying O, I might say PM. So therefore, side PM, or length PM, is equal to sine of 72 times 11. Okay, sine of 72 times 11, let's work that out. Sine of 72 times 11, that's 10.46, etc. Okay, now I have that length there. I have two sides of that right angle triangle. Let's go ahead and use Pythagoras' theorem to work out OP. So OP is going to be the square root of the hypotenuse squared. In this case was PM. PM I just worked out was 10.46 approximately squared. Subtract the other leg squared. OM was half of AB. So half of this number, I might just try to work that on the calculator quickly. So I wanted that previous entry and then divide that by 2. Okay, so that was 3.399, about 3.399 squared. And then let's plug that into a calculator. So I might do 10.4616. Okay, so it's always good to put in a few extra numbers just to get that bit of extra accuracy. Squared, subtract our previous answer, squared, and final answer there, 9.89 to 3 significant figures. So let's use an approximation symbol, 9.89. Okay, so that is my final answer there for question 21 for 4 marks. Not sure, there might be a simpler way or a quicker way to do that, but that was my method. I hope that made sense. Okay, on to the next one. Question 22 gives us a diagram. It says a regular pentagon is drawn inside a circle of radius 6.8 centimeters. Each vertex of the pentagon lies on the circle. Find the perimeter of the region shown shaded in the diagram. Give your answer correct to 3 significant figures. Okay, so they've drawn in the radius and they tell us this is a regular pentagon. That means all the angles are going to be equal. Alright, so what I want to do now is focus on this shaded area. Let's draw 2 radii to make a triangle, and what we're going to want is the length of this arc. So you need to know the formula for the arc length. And also I want the length of this triangle in here. Now I know these are two radii. I know their lengths are going to be equal. Also, I can work out this angle in here. Let me show you how I can do that. Let's call that theta. Now in a regular polygon, such as a regular pentagon, if I split it up like this, all of those angles in here are going to be equal because all the angles in a regular pentagon are equal. So to work out that angle, theta, I can use the fact that angles around a point add up to 360 degrees. And if I were to draw in 5 triangles here, all of these angles would be equal. So to work out one of those angles, I can do 360 divided by 5. That's going to give me theta. 360 divided by 5, that's going to be 72 degrees. And so I know that angle now. What I have here is a triangle with an angle and 2 sides. And when you have an angle and 2 sides, you should know that you can use the law of cosines, the cosine rule, to find the other side. Okay, so the cosine rule says a squared equals b squared plus c squared. Take 2bc cosine a. This angle is the angle between the two sides you know, and it gives you the missing side. So plugging everything in here, I know these sides are 6.8, so I'd have a squared equal to 6.8 squared, or 2 lots of 6.8 squared. Subtract 2 lots of 6.8 times the cosine of 72. And you don't have to use the cosine law here. Actually, you could have worked out these angles and then used the law of sines, or any method really to work out this side. But anyway, let's continue. So put that into a calculator, and actually this should be 6.8 times 6.8, b times c. Sorry, so 2 times 6.8 squared, take 2 times 6.8 squared, multiplied by the cosine of 72, equals 63.9, take the square root of that, and we get 7.99, etc. 7.99. Okay, so that's A. In other words, that's that length. Now we need the arc length. The arc length is the fraction of that angle of the total. So in other words, the theta, the angle of that triangle, divided by 360, multiplied by the circumference of a circle. Now you also need to know that the circumference of a circle is 2 pi r. That's the other thing you needed to know here. So 2 pi r, and then this is going to be 72 over 360 multiplied. Well, actually, if we go back here, we would know that's 1/5. So let's just write that as 1/5. Save us a bit of work putting it into a calculator. Multiplied by 2 times pi times r, which we know is 6.8. Okay, let's plug that in now. We would have 2 times pi times 6.8 divided by 5, and we get 8.545 approximately. 8.545. Okay, so we have that arc length, and remember we're looking for the perimeter. So we have the arc length, we have the length of that edge of the triangle. We just need to add those together to get the total perimeter. So 8.545 plus 7.99, and we need to round this off to 3 significant figures. So let's add that to 7.9938, and we get 16.538 to 3 significant figures, 16.5. Okay, final answer there for question 22, 16.544 marks. Just another quick look at the working out. So you had to work out the length of that triangle. I used the cosine law, but you could have used the law of sines or something else, and then you needed to use the arc length formula to work out the length of that arc of that shaded region. On to question 23. Question 23 says a box is in the shape of a cube of side 11.5 centimeters, correct to 1 decimal place. A solid spherical ball has radius 5.1, correct to the nearest millimeter. The ball is placed inside the box and the box is closed. Work out the upper bound for the volume of the box that is not occupied by the ball. Show you're working clearly. Give your answer correct to the nearest whole number. Now for this you need to know the volume of a sphere, the formula for the volume of a sphere. This is not something you need memorized for GCSEs, so they should have given this to you, and they will give this to you in an exam, but the volume of a sphere is 4 over 3 pi r cubed. Again, not something you need to memorize. Okay, so how are we going to work this out? Well, we want to firstly find the upper and lower bounds for the ball, the radius, and then also the side length of the cube. So we could write the error intervals for those. So let's start with the cube. So we have this 11.5 correct to one decimal place. So then if we were to round this off to one decimal place, we could have had 11.45. That would round up to 11.5. And then the upper bound of that, well, what rounds down to 11.5? Anything up to 11.55. So make sure you use the greater than or equals to and the less than symbols correctly there. Then for the sphere, we're looking for the radius. That was correct to the nearest millimeter. So in other words, that's the same as saying one decimal place, because that when we measure something in centimeters, the first decimal place is millimeters. So this is going to be 5.05. That would round to 5.1, and 5.15 would, anything below that would round down to 5.1 to the nearest millimeter. Okay, I have the lower and upper bounds for the side length and the radius of each of those, and now I can work out the upper bound for the volume of the box not occupied by the ball. So what would that be? By the way, how are we working out the volume not occupied by the ball? We would do the volume of the cube subtract the volume of the sphere. Okay, so how are we getting the upper bound for that? Well, the upper bound is going to be the largest possible area for the cube, the largest possible volume for the cube, subtract the smallest possible volume for the sphere. That would give us the upper bound of the volume that is not occupied by the ball. So what we want to work out is the upper bound of the cubic volume, or the largest value of the cubic volume. This would be taking the upper bound of the side length of the cube, 11.55, and cubing that. That's how you work out the volume of a cube. 11.55 cubed, that is 1540 well, all of those decimals really. Let's just write all of them down. Okay, so that's the upper bound of the volume of the cube. Then we want the lower bound of the volume of the sphere. Okay, that would be taking the lower bound of the radius and using that in the volume of the sphere formula. So we need to use this formula that they should give you, 4 over 3 pi times the radius 5.05 cubed. Let's put that into a calculator and we get 539.464, etc. Alright, now using this idea, we subtract those and it should give us our answer. So 1540.7, subtract this. So now let's put that into a calculator. Now we could just do those again, those calculations again, just to make sure it's as accurate as possible. So subtract all of this and we get an answer of 1001.334, etc. And go back to the question. It said to give your answer correct to the nearest whole number. Okay, that's nice. So look at the number after the decimal point. It's less than 5, so this number is going to stay as is. We do not need to round up. So final answer there, rounded to the nearest whole number, 1001. 1001, let's use approximately 1001. Okay, centimeters cubed. Okay, that was question 23 for 4 marks. Just a look at the working out again. We had to work out the upper and lower bounds of the side lengths and the radius of the sphere, and then you had to realize that the upper bound of the volume is going to be the largest, or the upper bound of the volume of the cube, take the lower bound of the volume of the sphere, and once you've done that, you should get 1001. And that is the end of this paper 3 of set 8. I hope you found that useful. Please leave a like if you did. Likes are always really appreciated. Subscribe if you want to see more content. If you're after paper 1 or paper 2, there should be a link to the playlist in the description, so check that out. Leave a comment if you had anything else to add, if you have different ways of solving problems, if you need clarification on a particular problem, please ask away. I'm always happy to answer any questions in the comments, or of course if there are any mistakes, let me know in the comments as well, because it helps people in the future coming to this video. And also I would just suggest make sure you double check before you leave a correction, because sometimes people get put off by people leaving what they think is the correct answer, but actually it's incorrect, and then people get confused. So anyways, thank you for watching. I hope you found that useful, and I'll see you in the next one. Bye for now.